This is a 3D representation of our cat, Mimi. This was generated from 75 photos taken on a cold January afternoon here in St. John's, Newfoundland. A slice of reality was captured and is now represented in 3D. It's a cat-scale slice of reality, but it's a piece of the real world made digital nonetheless. My name is Aylward. I graduated from IMD in 2017 and moved to Newfoundland and Labrador to work for an environmental consulting firm called SEM Limited. I started out working on virtual reality projects, then quickly got absorbed into the world of drone operations and reality capture, which is what I'll be talking about in this video. Back to my Mimi model. From just 75 photos taken on my phone, we can generate a 3D mesh, a cloud of points called a point cloud, and other 3D representations like Gaussian splats. But what if we bump the scale up? Part of my work involves using drones to capture aerial photos and other data from industrial operations like mine sites. From hundreds, thousands, or even hundreds of thousands of photos, we can process out deliverables like maps, elevations, and point clouds. Each photo taken is accompanied with metadata like the drone's pitch, yaw, roll, and its coordinates. Using photogrammetry software, we can get positionally accurate maps with resolutions reaching around 3 to 5 centimeters per pixel. These maps are also called orthomosaics because they're a mosaic of orthogonal or top-down photos. Orthomosaics can be used to measure lateral distances and areas on the ground and are generally higher resolution than publicly available satellite imagery. Elevation models are typically 2D representations of real-world heights. They can be thought of as real-world bump maps, where pixel values represent how much a surface is elevated. Point clouds, on the other hand, are 3D representations of surfaces, where each point is a confirmed XYZ coordinate in the real world. Point clouds can be segmented down and classified into groups of points which represent objects or distinct surfaces. They are great for volumetrically measuring things like stockpiles and for measuring distances between points in 3D. For even more accurate point clouds, you can swap a camera out for a laser scanner, so each point returned is a discrete real-world location instead of a point interpreted by photogrammetry software. But where does reality capture intersect with multimedia? Well, thanks for asking. Photorealism in video games is a great application of high-resolution reality capture. Companies like Quixel, for example, make what they call megascans, which are photorealistic 3D meshes and textures made using photogrammetry and 3D scanning. Meshes derived from reality capture can also be used as a reference for 3D modeling, like if you needed a reference for scale, shape, color, etc. Larger scale captures could be used as a reference for level design in video games too, if you wanted the real-world environment remade to spec. Apart from meshes, there's also the orthomosaic map and elevation model outputs to consider. You can generate a 3D terrain using an elevation model and an orthomosaic by deforming the orthomosaic by the values held in the elevation model. That terrain can be used for a variety of purposes, like for renders, as the terrain in a flight simulator, or something I've been increasingly interested in, for community consultations. Big projects like mines or wind farms need a social license to operate. Before construction starts on any project, an impact assessment occurs, which encompasses environmental, social, and economic effects. Community consultations are a part of these assessments. Where reality capture plays in is helping communities visualize what a future development might look like. You can accurately recreate an area in 3D, then insert scaled meshes so that community members have a better understanding of the potential development. Once it's in a game engine like Unreal Engine 5, you can develop different outputs like high-resolution stills to show a before and after, maybe a virtual reality app, you name it. The field of reality capture is improving every day, with better sensors, faster processing, and newer ways to visualize your data. This technology is having a real impact in communities and multimedia right now. Just imagine what it'll be like in the future.